Hey everyone, so this is the second part for lecture 1.2. We're going to move into sampling. So the sampling, we've been talking a lot about sample and population and parameter and statistic. So now we're really going to drill down into what kind of sampling we can do. Because as you recall, we know that population is to parameter, meaning there's some sort of number or measurement about the entirety of the group we're looking at, which is the population. And instead of kind of asking everybody to get a handle on what this parameter is, instead we ask just a few people, and few is in air quotes here. So we get our sample, and from the sample, we get a statistic. And the statistic will be a good match for the parameter if the sample is representative of the population. So there are lots of measures of goodness, and we'll definitely get into more of them as the semester progresses. So right now we can think of a good sample as just a sample that really represents the population well. So for example, if you had a sample, let's say we wanted to do a study on San Jac students. So I got a sample of, let's say, 100 students, but they were all 18-year-old females from Channelview. That's not really representative of the San Jac population. You know, I would need gender diversity, I would need geographical diversity, I would need age diversity, because we're such a diverse campus. So those are the things that we want to think about when we are creating a sample. So the first one that we're going to look at is just a simple random sample. So that's basically, you take the whole population and you randomly pluck out however many people you want in your sample. And I feel like randomness is really taken for granted because it's a pretty cool thing. I'm going to show you a little bit later on how to generate some random numbers in Excel and then how to use those to create a simple random sample. So in the simple random sample, every person has an equal chance of being selected from the population. The other types of sampling we have are stratified and cluster. So a stratified sample is one that divides the populations into groups, which in this way you would make the groups, in this way you would pull a random sample from each of the groups. So maybe a good example would be something like this. So let's say that you have can be just a pie chart for San Jacinto College, and I'm 100% making this up. And let's say I wanted to do a study on the early high school students that attend San Jac classes at North Campus. So I'm going to have to look at students from Galena. I'm going to have to look at students from Sheldon. I'm going to have to look at students from, oh my gosh, what's another one? I'm supposed to know this, I don't. Maybe we have students from Channelview coming in. I'm just gonna make this up. So this can be, I don't know, we can just call this Deer Park. I also did not go to high school in Texas, so it's really hard for me to like remember what high schools are in the area. Okay, so we can see here that the biggest cluster of students of early high school students that we have at San Jacinto College, theoretically per this pie chart, come from Sheldon. So that means that Sheldon should have a bigger representation in the sample that we draw. And so the way that I would do that is I would kind of take proportional amounts from Sheldon. So let's say if Sheldon had 60%, and then maybe we could call this, this is not 60%, don't be dumb, Kelly. Let's call this 45%, 25%. So now we're at 70%. So we'll just call this 10% and 20%. So that means that our sample should have 45% of its representatives from Sheldon, 25% of its representatives from Galena, 10% of them from Channelview, and 20% of them from Deer Park. And so by grouping them into these strata, right? So now Sheldon is a strata, Galena is a strata, Deer Park is a strata or stratum, then you can pull little individual samples from each one. So what would happen is I would pull, so remember we talked about the simple random sample above, that's everyone has a fair shot of being in the sample, or as they put it, every sample of the same size has an equal chance of being selected. So that means that I would have my sample of Sheldon folk, and then I would have my sample of Galena folk, I would have my sample of Channelview, and then I would have my sample of Deer Park. So I'm pulling now simple random samples from each of the strata, and then together that will make my stratified sample. So an interesting way to think about this might be if you consider the House of Representatives. So we know that every state gets a certain amount of representatives based on its population size. So let's say that people weren't elected and that we just chose someone randomly. I'm not sure how different that would be. So if we chose someone randomly for a representative from the state, right? Then the House of Representatives would actually be a perfect example of a stratified sample of US citizens, right? So pulling a proportional amount from each state. Texas would get a whole bunch. All right, so we also have a cluster sample. So you divide the population into your clusters or groups, and then randomly select some of the clusters. And all the members from these clusters are in your cluster sample. So now how would this look if we were still doing the early high school kids that attend Sam Jack North? So if I were to do a cluster, that means I would randomly select one or more of these individual groups. So a cluster would look like, I want to know about my early high school students here at Sam Jack North. And so to do that, I'm going to actually just maybe make my study all of the Deer Park kids. And I would just take that whole group of Deer Park first year students. Right, so this would be a cluster. Where Deer Park is our representative. Right. And then remember here, this was our stratified, where we are making the different groups and then doing a simple random from each group. So it's really important to keep in mind the proportionality for stratified. All right, so there's a couple more. We have systematic. So systematic requires that you put people into a list. So the list doesn't really have to have any qualities to it. You could sort them, you could alphabetize them, they could be grouped or whatever. The list could also be totally random, but like, let's say, you were using the phone book and you were gonna kind of do a phone survey. By the way, a phone book is what we used to use when we had to call people and we didn't have Google. So everyone was listed in there alphabetically, which is terrifying. So if you wanted to do systematic, you would start somewhere. Like, let's say I'm gonna start in the 10th position or start in the first position or start in the 100th position. So that starting point is chosen randomly. And then from there, depending on how many people you want and how many people you have in your population, you're gonna select every 100th person or every 50th person or every third person. So like if I wanted to get a systematic sample from our class, I would just pick a random number between 1 and 23 or 24. And then I would have my list of all y'all. I'd have my random number between 1 and 23, and that's going to be my starting point. If my random number was number 1, I would start at the top of my roster. If my starting point was 13 or 12 or whatever, it would be about the middle of the roster. And then depending on how many people I wanted, I would just jump down a few steps. So again, we'll do some examples. Well, we're about to do an example right now and going over each type. We may do some examples in Excel of how to create systematic, stratified, and convenience sampling as well. Our first task is going to be to do the simple random though. So the last one is going to be convenience sampling. This is probably the easiest one to understand. It's totally not random. It's exactly as it sounds. So like, let's say I wanted to get a sample from our class, like, maybe pick 5 students. Okay, so maybe I would just pick the first 5 students to answer my questions about the class based on who comes to my office hours first. So, there's lots of different types of students. There's students who are going to come to office hours every single session, which is great. You're welcome. There are some students that are going to come to office hours only when they have a question on something, which is maybe like once a week, and that's fine too. And then there's some people that will never come to my office hours at all, which I would say is most. And they may go instead to Sandjack tutoring, or they may ask, a friend for help or a hired tutor or whatever. Those first 5 people that come to my office hours, that's typically not a good representation of the class as a whole. I could still do it. It would just be a convenience sample. All right, so let's do some examples and determine which kind of sampling we have for each of these. So if we can just make a little cheat sheet right here. So we know that I'm going to write SRS is simple random sample. And so everyone is equally likely to be chosen. And then we had our stratified. And so this kind of, you do a SRS proportionally from each group. And then we had our cluster, as you kind of choose one or more. So again, writing 1 plus, kind of subgroup to represent the population. And then the last one was convenience, which is exactly as it sounds. Just imagine that you are being very lazy and you just need to ask people some question. What's like the easiest way to get a sample from your target? Okay, so that's a bit better there. All right, so let's look at the first one. A sample of 100 undergraduate San Jose State students is taken by organizing the student's name. Oh. I forgot to write systematic. So that's pick a starting point. Remember, your starting point has to be random. So pick a starting point randomly. And then I'm just going to say, and jump evenly. All right, so a sample of 100 undergraduate San Jose State students is taken by organizing the student's name by classification, freshman, sophomore, junior, or senior, and then selecting 25 students from each. So we're breaking them into groups. So A in this case would be stratified. The one tiny issue I have with this is that we're making the assumption in this example that we have an equal amount of freshmen, sophomore, junior, and seniors. And I think typically in a college, you have slightly more freshmen than you do have seniors just because of attrition. So that aside, I'm going to take 25 students from each, and this is the assumption, a simple random 25 from each. So this, I want to just add the note here that we're going to assume San Jose State University has equal amounts of freshmen, sophomore, junior, and senior. So remember that remember that stratified has to be proportionally, it has to respect the proportion of the population. So that's why this little note here is important. Okay, so A, we are stratified, now that I've made that little correction. So this is going to be strat. Okay, the next one, a random number generator is used to select a student from the alphabetical listing of all undergraduate students in the fall semester. Okay, starting with that student, every 50th student is chosen until 75 students are included in the sample. So that perfectly describes the systematic sampling method. So I'm just going to write SYS. All right, the next one, C, a completely random method is used to select 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the sampling process. So that really describes kind of our alternate description that was different from the text a little bit of simple random sample. So I think of simple random sample as everyone has an equal chance or an equal likelihood of being chosen from the population. The way they wrote it, which is very interesting, is that every sample of equal size, every sample of the same size is equally likely to be chosen. All right, D, freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4, respectively. A random number generator is used to pick 2 of those years, and all students in those 2 years are in the sample. So what they're saying here is that you're breaking up, you're classifying each student as either a freshman, sophomore, junior, or senior by breaking them 1, 2, 3, 4. And then you have a random number generator that's going to randomly pick 2 numbers from 1, 2, 3, 4. So if you pick 1, 2, that means you're taking all the freshmen, all the sophomore. If the random number generator selected 2, 4, that means you're taking all of the sophomores and all of the seniors. So because we're taking all of one or more particular group, that means that we are a cluster sample. All right, and then for E, I'm gonna scooch this over. The spacing is driving me insane. There we go. Okay, so for E, the last one, oops. An admin assistant is asked to stand in front of the library one Wednesday to ask the first 100 undergraduate students he encounters what they paid for tuition. So again, not every student is going to go to the library that day. The patrons of the library at San Jose State is perhaps, I'll tell you right now, it's commuter school. So, you have to think about that. Are the patrons, is that a good representation of all the undergraduate students at San Jose State? Maybe not. If you're a working person and you're going to a commuter school, you probably have other stuff going on in your life. You may not have time to go to the library. So these first 100, it's just a convenience sample. It may or may not be indicative of the actual population of the undergraduate population there at San Jose State. So this is a convenience sample. All right, I felt like okay, I know what we're doing next. So I'm actually going to end the lecture recording here because the next thing I want to do is I want to go through Excel with you guys, get you started using that as best I can from, a distance learning perspective. And then I want us to create from a data set a simple random sample. And then depending on how that goes, we can work on creating stratified, cluster, systematic, and I guess convenience. So that will be the next video. If you have questions, definitely email and check out the alternate and supplemental videos that I've posted for this topic as well. Thank you so much, and I will talk to you soon.